Hello everyone, welcome to lecture 14. Today we're going to talk about attribute data. Basically, we will focus on joint and relate. In our previous lecture, we have spoken about the the fact that sometimes, many a times, the data that we have, it's already in this format. Whether you fill a form to attend an event, whether you fill a form to register for a school, filling a form online for access to software or something. Anything that you do in a day, you fill a form. And basically, these forms, no matter the medium you they collected it. If you filled it by hand, if you filled it on the computer or on the web, or whether you actually had to mention this information to someone to write, no matter how it is, they end up in some sort of Excel sheet like this. And this is how mostly we try to capture the data and we try to analyze the data. However, this data doesn't have an explicit location information. We talk about the fact that in GIS we are not just only interested in locations like just Los Angeles, London, Chicago. We want, most of the time we are interested in the X and Y coordinate. And so what is lacking is that we go to the field and we try to pick this information. And most of the time, you would find yourself in a situation where the information you already need, the details you need, it's already in an Excel form with an organization, or probably you have acquired that information already. However, it does not have any location. So you either go to the field to collect this information yourself, or you get this location from someone else who also have the location that is the X and Y. Now, when you get this information, how do you connect or how do you link the information that you have received from the raw informations you've received from one entity to the GPS location you have collected or you have received? And that's what we are going to talk about today. And it's basically concerning data cardinalities. Okay, so with cardinalities, we are saying that it's a numeric relationship between objects in one table and how it matches in another table. So we'll go a bit deeper and we'll talk about more in these cardinalities. First of all, in GIS data cardinalities, we are talking about one-to-one relationship, one-to-many relationship, many-to-one relationship, and many-to-many relationship. Now, these relationships that we're talking about is basically relationship between one table and the other table. So there are two tables here or two or more tables, and they kind of have a relationship. However, they are not in the same data or in the same database, and so you want to be able to find a way to merge them. In attempt to do that, I want you to think about this. You would need to have a good understanding of key, which is the basic one I would focus on for now is primary key and foreign key. You also have to understand direction, as this is very inherent in most of the softwares that we use. There is direction and cardinalities. And secondly, we are looking for linkages. Okay. So with that, you would be able to, if you understand these three concepts, which I'll try and go into a little bit for what I think is enough for you to be able to understand this topic. But you are free to dive a bit deeper and understand. And maybe when we are dealing with database, we'll talk more detail about keys. Now the key, the linkage, and the direction is what I want to focus on this at this side. Here we if you look at, there's one table here concerning a parcel, the zone it's in, and then a block the parcel is in. There's also another table here concerning whether the description of the parcel, is it a parcel zone for residential, commercial, or industrial purposes. And we have these informations. We want to be able to link it to the parcel. Now, one of the things we will need first is a key. We need a key because if we have residential, commercial, industrial, and then we have the parcel IDs with their zones, there is no common field here. How do we tell which one is connected to which? However, if we have a key, something like this, so if we take the zone, it has informations 3, 2, 1, 2. And then if you come to the zone here, it also has information 1 and then 3. There are common informations, the same data type, and it's the same structure. Okay, so once we have this information, we can use these to connect to each other. So 1 will connect to 1, 3 will connect to 3, and in that order. Now, one of the things you would have to know is the fact that when you are trying to do this, sometimes the key that you find is not necessarily. So let me use this example. You have a currency rate here, which is basically sales, and then we have a sales order, which is also part of the sales database or the sales data. However, we have a currency rate ID here, and we have currency rate ID. Now, the question you ask yourself is, this is a currency rate data, so we are fine if it has currency rate ID. But what is currency rate ID doing in sales order header table? And that is where we bring in the concept of primary key and a foreign key. At this place, this is a primary key because this has a relationship, or this belongs here. It's a currency rate and it has a currency rate ID. And so it makes sense to have it there. This currency rate ID here, it's a foreigner in this table. We don't need, because this table already has sales order ID. And so the currency rate ID here is only here as a foreigner. And the reason is that we intentionally put it there. We try to match the same, create a similar ID there so that we can use that to connect to this table. So the currency rate ID here is called a primary key, and then the currency rate ID here is called a foreign key because it is foreign in that sense. We don't need it necessarily. The table can work without it, but we are looking at it, or we are putting it here because we want to be able to link and tie them together. I hope I've been able to explain this well. The last thing I want to talk about is direction. Now, if you look at this, direction is a bit tricky, so I hope you will get me. There is no conventional direction when it comes to cardinality because software developers sometimes inherently define directions in their data or in their software. So when you are using a software, you need to pay attention and get to understand the directions. You might find one or two or three using the same method, but it doesn't make it conventional. You always have to check what the direction is. For instance, if we say 1 to 1, you might be forced to think of uh, the origin. Every table has an origin and then has a destination. So you have if you have two tables, there's one that you want to put the information into. And then if you have these tables, sometimes we call it the origin and the destination. At other times, you will see source. So the origin becomes the source, and then there's also a destination. Now, if we say 1 to 1, you're likely to think about it as 1 to 1 because, if you are not, unless the people who write from right to left, if you write from left to right, you are likely to start from your left table to your right table. However, some softwares, if you do this, it is wrong because that's not the logic inside, or that's not the logic they are using, the conventional logic of direction they are using. So if you are using SU product, since it's the it's the most used softwares in GIS. If you're using SU product, we're actually looking at it from the opposite. So it is the origin to the destination in a reverse form. So if you look at it, if you do origin to destination from right to left, you will be wrong. But if you do from left to right, then you will be right. Okay. So this is how the software works. This is how the software does the connection. You need to understand this because you would not know which table to connect with which and how it's going to behave if you in your mind you are doing a different connection and you cannot even assess whether it's right or wrong because you have a different expectation as a result and you will get a different result in the end. So this is what we mean by key linkages and directions. Like I said, directions are very important. Key is important because we need to be able to connect them, and if needed, we create artificial key in tables that they are not needed just to be able to create a foreign key and connect to a primary key. There is no directional convention to the table cardinalities. It is mostly predefined by the the software you are using, and you always have to check out what it means, how it is done in your software, and then you use that. Now let's talk about joins. We've talked about the linkages, the directions, and then we've also talked about the keys. Now, how do we practically use them? The rule for join is that there must be only one record in the source table for each record in the destination table. So if you have a source table, there should be one record in that source table that matches with the next record in the destination table. So just one for the source table, we just need only one record. But in the destination table, we can have multiple records. So I'll explain this when we come. So this is a one-to-one relationship. Imagine you've gone to the field to pick data and you have the coordinates of this data here. However, you have actually received a list of shops and other informations that you would want to, let's say, you want to tie them to the shop and use them for your mapping. Now you go to create an ID for this table or for the locations you've created, which is called an ID and it has 0 to 4. And then you come and create a foreign key, which is the location ID. So the same ID, but this time around, you are using the ID based on what the place is. So these IDs are actually matching with the location, just that you don't have the location inside this table. So you see that there's a destination table and there's a source table. And now with the destination and the source table, you can match them. Each record is actually matching with each record in the source table actually matches. There's only one record in the source table that matches with a record in the destination table. But you see that this is just one record matching with one record. So it is like a one-to-one relationship. And I did it this way so that you understand what I mean. I've already said that it's a reverse. So when you see this, reverse it. It's rather we are actually coming from right to left in ArcGIS softwares. Okay. I think which is mostly likely what many of you would be using. This is a many-to-one relationship. In many-to-one relationship, let's review the rule again. The rule says that joining a join table, if you want to join a table, there should be only one record in the source table that connects to each record in the destination table. Now imagine that this location or these shops are in a multi-complex or in a story building. If that's the case, um, one location can relate to multiple shops. And so we have one record here and only one record here, and it connects to, so the same Julie Hair and then P Pharmacy are found in the same building, so they have the same location. Whilst Ama Phones and City Malls also have one location, so they relate to the same uh, coordinate. And so in this, we are saying that we have many to one relationship. Okay, so that's how it is. We make it sound like we make it's a bit confusing, but I hope you get it. So we are saying many to one, that we are reading from left to right, but in practice we are actually reading it from right to left. Okay, so that's how basically we read and interpret this uh, tables. Now, there's also one-to-many relationship, which we've already spoken about in our previous slide. Now, one-to-many relationship, let's look at this. So there's um, a table that has information about the the names of owners of a parcel, and there's a table that has information about these parcel, whether they are residential, commercial. We have these informations, and then we have another table that also has information about ownership. Now, one person can own more than one parcel. So some has multiple parcels, and we want to be able to connect them. Now we are getting one-to-many relationship. A one-to-many relationship, the owner being the owner table being the source, and then the parcel table being the destination. Realize that we would find uh, many to one person having, or some having access to many lands. And so this rule that we have here doesn't work. And so we are looking at it from one-to-many relationship. We are saying that the person, the table has, in the source table, it has one record, but it's the one record is not just to each record in the table, but it's actually to multiple records in the destination table. Okay, if that happens, this rule is no longer happening. This is no longer working because it is not one record in the source table for each record in the destination table anymore. Okay, so if you have this situation, then we are dealing with a one-to-many relationship, and in this case, we cannot join them because you wouldn't know how to join them. For instance, it's very confusing to know how you are going to join some to these three different records, because if you are joining them with an ID, all these have different ID. Some has just ID 3, and all these have different IDs. How do you join them? So what we do is we do relate, and I explain relate a bit here. So when we do relate, we are saying that there's one record, and for instance, here is the US teams, and then here is the NFL players. Now, the NFL players tells you about the name and the player name as well, and we also have information about uh, the team, the location, or where the team that we are talking about. So Jimmy plays in San Francisco 49 years, and then we also have Houston Texans, and we have Houston Texans here. But if you look at this table, we see that Houston Texans has we have about three of them in the source table, and we have one Houston Texans in the destination table. Now we don't know how to connect the same name to just one record in the table. So what we do is that you create a relate. A relate creates a relationship between the source and the destinations table, such that he knows that this is related to, so San Francisco, Houston, Texas are related to uh, Deshaun Watson, JJ Watts, and then Hopkins. And once he knows that there's a relationship between them, he keeps the two tables separate. But whenever you click on Houston, Texas, it's going to pop up these all the players that are related to Houston, Texas. The idea is that this table here is actually not a real table. This is just for your view. So it is a temporal table that is created because and behind the table a relationship has been created such that it will be able to tell you those information, but it cannot store them because it is too complex to store. We do not know how to store such a complex relationship. And so you need to understand the instances when you will need to use join and the instances where you will need to use relate. Relate is basically for one-to-many relationship, and join is for one-to-one, many-to one relationship. Now, there's also many-to-many relationship, which is also defiling the principle of join. So we have to use relate. However, it is even more complex with many-to-many relationship. When the same record, for instance, you have a class where there are so many classes or there are different subjects. A student is offering multiple subjects in the class table, and the class also has multiple students in the students table. Relating this is quite difficult. Sometimes what we do is that you create the relations in batches. You first create a relation between the students and the class, and then you create another relation between the class and the student, and that's how you try to do it. But it is a more complex stuff, and relational databases are not good for this complex relationship. And this is something I want to draw your attention to. But think about, this is one of the weakness of using relational table or relational database. So if you are making a choice to represent a data, you need to understand these relationships and understand the databases that are available, their strengths and their weaknesses, so you can make a good choice. However, in this discussion or in this lecture, we are only talking about relational databases. And so I would not talk about any other database because this is basically for us to understand joins and then relate. Okay. So in summary, we have looked at cardinalities. We have tried to understand key directions and linkages. We've also tried to understand instances where you need to use join, and it's basically one-to-one relationship and when you have many-to-one relationship. However, when you have many-to-many relationship or one-to-many relationship, there is a you have to use relate if you are using relational database. I know that this can be confusing, especially when it comes to the direction. Sometimes I get confused myself. You always have to look out for which one is the source, or which one is the origin, and which one is the destination table. And you always have to, even though you are reading it from left to right, you always have to, in practice, look at it from right to left. And that's the way it will make sense for you when you are using ArcGIS software. However, if you are using another software, you will just have to, if you don't know, if there's no documentation anywhere about it, what you have to do is to keep the default ArcGIS direction in your head and try a small relate and check the results. When you check the results, you'll be able to understand what is happening. But at least you are aware that there is a direction and you need to look out for the direction to enhance the credibility of the relationship you are building. If not, you're going to create a false information. You are going to give a location of one place to another feature which is not needed because you have missed the direction, and it's doing probably a many to one relationship when you think that they should do one to many relationship. Kind of, that's how we basically look at it. But I hope that this lecture has been insightful. This is an intuition lecture. I do not intend to teach like I'm teaching in a classroom, but what I seek to do is to give you a very good understanding of the general concepts, the whys and the whats of what you are doing practically in your one-on-one class with our instructors, so that you will be able to make sense and make good decisions as you do your project. It's very important to consider joint and relate because there are so many data we already have which has no locations, and we would always have the need to pick locations or get location informations from them if we want to use them in a GIS platform. And once we get that, we would have to find a way to do a join or a relate. The most common databases you find in GIS is a relational database. Yes, now there are more other databases coming like um, graph databases and then the document databases, which they are trying to make it spatial capable, but they are at their early stages of their spatial capabilities. So you are likely to find more relational databases. So this is likely to be one of the approaches you'll be using when you're trying to join, uh, create relationship within a data. Now remember, there is a relationship in the real world. Everything in the law of geography says all things are related to all things, but near things are more related than distance things. So there's always some sort of relationship, and that is what we have at the back of our minds. And you would always have to create a relationship, no matter how the data came to you. And this is one of the approach. I'll see you in lecture 15, where we would go more detail and we'll talk more about more concepts in GIS. I hope that this lecture has been insightful. Until then, I'll see you.